With all of the equipment ready to go, and the time of the event predicted down to the second, the only thing left to do is to wait for the sun to set and for Jupiter to rise. As Jupiter comes into view, we aim our telescope at the distant planet. We've set up a dew shield on the end of the telescope to keep the optics dry, and we are repurposing a green screen to keep the telescope steady during any winds that might crop up. We first align the telescope with Jupiter and enable the tracking to keep the planet centered in the field of view. If you look carefully, you can see the telescope sidereally tracking, slowly correcting its position to keep Jupiter in view as the night goes on. Once Jupiter is centered and tracking, we calibrate the focus and camera settings to avoid under and overexposing the planet. Seeing Jupiter pop into view never gets old. The banding in Jupiter's atmosphere, due to its rapid rotation of only 10 hours about its axis, is immediately visible, even in the live view. We've begun recording now. The camera is saving exposures to a large-scale storage medium at over 200 frames per second, which means in our few minutes per exposure, we'll be able to capture 30 to 40,000 frames, ideal for lucky imaging. It's only a few minutes, but each exposure requires several gigabytes of storage space to save. We'll repeat this process every 10 minutes or so for a few hours, which will let us make a time-lapse of Jupiter and the Galilean moons, and see if we are able to reproduce Galileo's fateful discovery.